I've done it. Partner, brother. I got it.
Got what?
I got our battery right here.
We're good for steel.
Going on here? Now, why don't you spin right here, man? I mean, what should we got all these different materials for? Okay. Over here we got the copper. This copper right here is our cathode. It's gonna be producing some negative charges. This right here is our lead. This is our anode. It's gonna be producing some positive charges. Now, each will be placed in their respected liquids. This is a copper solution of CuNO3. This is a lead solution of PbNO3. And when connected by wires in this here salt bridge, we're in business, buddy. We're in business. Good.
The boys plan to build a battery using the anode lead placed in a solution of PbNO3 and cathode copper in a solution of CuNO3. Each electrode will be linked together through a voltmeter to check the voltage. If the boys have done the calculations correctly, their battery should yield at least 0.26 volts. Each half cell is also linked with a salt bridge soaked in potassium chloride. When we come back on Battery Makers, is the season over for these boys? A run with the law may ensure their fate.
What's that?
The law!
Duracell batteries can make fun times last a lot longer. If you put Duracell batteries into one toy and ordinary carbon batteries into all the others, you'd find that after just a few hours of continuous use, the ordinary batteries give up. But Duracell batteries keep going. In fact, depending on the toy, Duracell can last 2, 3, up to 6 times longer. Duracell. The copper top battery. No ordinary battery looks like it, no ordinary battery lasts like it.
In the battery created, copper reduces and lead oxidizes. The copper is a cathode because it reduces in the battery. When copper reduces or gains electrons, its reduction number or charge of the reduced element is 0. The reduction equation is shown below. In this battery, the copper is the oxidation agent because it accepts electrons. Lead is the anode because it oxidizes in this battery. When the lead oxidizes or loses electrons, its oxidation number or charge of the oxidized element becomes 2 positive. The lead oxidation equation is shown below. In this battery, the lead is the reduction agent because it gives off electrons.
I sure hope this works.
Negative, negative. Positive ground. My bad, I did it backwards. Negative, negative.
Brother?
Positive ground. Alright.
0.45 volts. There's a good battery.
The battery that is created is a voltaic cell because it uses chemical reactions to produce electrical current. The study of the relationship of electricity and chemistry is electrochemistry. The voltaic cell is made of 2 half cells, each containing a half reaction. A half cell consists of metal being oxidized or reduced in a solution of its ions. The half reaction of the lead and copper cells are shown below. The oxidized and reduced element can be determined on the activity series. The higher metal in the activity series, in our case, is lead, and therefore it is oxidized, and the anode, while copper, the lower element on the activity series, is reduced.
Me and my partner are in a bit of a fight over the accents.
He won't understand my feelings or what I'm trying to say to him. He thinks his way is the best way.
I just don't know if this is gonna work. We hit a wall. This is a series battery. In the series battery, the cathode is connected to the anode of another cell
and the anode is connected to the other cathode of this cell. It's called a series battery because it maintains the flow of electrons following from positive to negative.
Alright, so instead of having a series now, we have a parallel. So we have the cathode of copper, which is connected to the anode of lead through this salt bridge. The lead is then connected to another lead through this wire here, which is connected to the salt bridge and another copper, which converts back to the first copper, completing the circuit. It's called parallel because instead of having these switch where it would be a continuous series, you're copying what you did the first time and putting it in there the second time.
To predict the voltage of any battery, first look in the activity series and see which metal is higher. The higher metal is the anode. Once you've determined which metal is the anode and which metal is the cathode, you can go and find the oxidation potential. Once you've found the oxidation potential, you add it to the opposite of the reduction potential. This will yield you with your potential for the battery.
The law!